Today we are going to start adding rational expressions, and again, rational expressions are just fancy name for fractions with variables in them. So before we even get started on that, let's talk about how do we just add fractions. So in order to add fractions, you have to have, and don't feel like you need to write this example down, just watch. To add fractions, you have to have common denominators. So most of you can probably figure out that for 4 and 6, the common denominator should be 12. Could you use 24? Yes, but that's going to make our numbers bigger, more work later on. So we don't want to do that. So the common denominator for 4 and 6 is 12. After you find that common denominator, you figure out what you need to multiply each one by to get to 12. So in the case of 4, you would multiply by 3. Whatever you multiply on the bottom, you multiply on the top. Then you go to the 6th, I need to multiply that by 2 to get 12. Whatever I multiply on the bottom, I multiply on the top. So I actually do that multiplying. 3 over 12 plus 10 over 12. Now I have common denominators. I add the numerators. 3 plus 10 is 13. Keep the denominator the same. So I get 13 twelfths. Then my last step is I look to see if I can reduce, which I can't. So I'm finished right there. Now, common mistake once you get to rationals is that you'll try to reduce too early. Just keep thinking back. I can't reduce until the very end. Because if I went here and reduced, so I reduce that, I get 1/4, guess what? I'm right back to where I started from. But with variables, people try to do that. Bad news. Only reduce at the end. So, here are the basic steps for adding rational expressions. First step, you're going to factor your denominators if necessary. Only the denominators, not the numerators. Only factoring the bottom. Step number 2, find what your common denominator is going to be. So just like in the last example, we found out that the common denominator was 12. Step number 3, you multiply both the numerator and the denominator to create the common denominators. Step number 4, we're going to distribute and combine like terms in the numerator. Notice nothing about canceling in here. You cannot cancel in here. Step number 5, keep the denominator the same. And then step number 6, at the very end, we can check to see if our numerator will factor to cancel with the denominator. So no canceling until step number 6. That's the biggest mistake. All right, so let's move on to our first example. We have 5y plus 2 over xy squared plus 3x minus 6 over 4xy. Now notice in this case, our denominators are not polynomials, they're monomials. So we do not need to factor our denominators in this case. We just need to figure out what our common denominator is going to be. So if we look at our numbers, we have a 1 and a 4. So the common denominator for that will be 4. We already have an x in both of them, so that's good news. And then for our y's, we have y squared and y. When you're making common denominators, you can't get smaller. You can either stay the same or you can get bigger. So we're going to use y squared here because I can't turn the y squared into a y, but I can turn the y into a y squared. So here's my common denominator. That's step number 2, to figure out what your common denominator is going to be. Step number 3 is multiplying to make that common denominator. So when I look at this one, I have the x, I have the y squared, I don't have the 4. So I need to multiply this by 4. And whatever I multiply on the bottom, I multiply on the top. Same thing over here. I have the 4, I have the x, I only have one y instead of 2. So I need to multiply by y, top and bottom. So now we're finished with step number 3. Step number 4 says to distribute and combine like terms. So we actually have to multiply this on the top. So we would get 20y plus 8, and over here we would get 3xy minus 6y. because I have to distribute that onto there. My common denominator should be the same at this point, so that's a good place to double check yourself. 4 times xy squared is 4xy squared. 4xy times y, 4xy squared. Not finished with step number 4 yet because I still have to combine my like terms. So 20y minus 6y, that's 14y. The 8 doesn't have a like term. The 3xy doesn't have a like term. Keep my denominator the same, that's step number 5. Now we're to step number 6, and we see if there's anything that we can cancel. But again, this top is a polynomial, so the only way we could cancel down here is if we can factor this guy, which we cannot, so this is our final answer. My restrictions in this case would be x cannot equal 0, y cannot equal 0, because x and y are the only things in the denominator. All right, let's do an example with polynomials in the denominator. So now again, we have to make our common denominator, but it's hard to see how in the world we would combine these two things together right now. So we want to do step number 1, which is factor. So if I factor this left side, I get x plus 5x plus 2. Factor this right side, I get 3 and x plus 5. Now I'm on to step number 2. I need to find my common denominator. So I need to figure out how I can make these two look the same. The easiest way to do that is this. You take everything from the first denominator and you write it down. X plus 5, x plus 2. Then you go to the second denominator, and anything that's not already up here, you put up here. So I have a 3. I already have the x plus 5 up there, so I don't need to put that again. All right, so here's my common denominator. So then again, step number 3, I need to multiply so that I make this common denominator. So on this one, I'm missing the 3. Whatever I multiply on the bottom, I multiply on the top. Over here, I have the 3. I have the x plus 5. I'm missing the x plus 2. So x plus 2, x plus 2. Step number 4, distribute and combine like terms. Again, no fair canceling here, that's bad news. 3 times 2 is 6 over my common denominator. Over here, 4x times x plus 2, that would give you 4x squared plus 8x over 3x plus 5x plus 2. Your denominators should be the same at this point, which they are, so that was a good double check. We still need to combine our like terms, which we don't have any, so we just write it in the correct order. Standard form starts with the squared and goes down. Keep my denominator the same. So there's my steps 4 and 5. Step 6, again, double check to see if anything here can factor and cancel. Well, I noticed that there's a GCF of 2, so I try to pull that out. That would leave me 2x squared plus 4x plus 3. So then I need to think about, will that still factor? Oops, that's a squared there. 2 times 3 is 6. There's nothing that multiplies to give me 6 and adds to give me 4. So this thing won't factor. I have this underneath it. And there's nothing here that can cancel. So this is my final answer. You could have left the answer here. That's okay, since it didn't end up canceling. So either one of these would have been okay. Your restrictions, x cannot equal -5, x cannot equal -2. All right, last example. Let's try just one more. So again, I have polynomials in my denominator. Step 1, factor. So 2 numbers that multiply to give me 6, subtract to give me 1. That would be 3 and 2. And if I want a -1, -3, +2. Over here, 2 numbers that multiply to give me 4 and add to give me 4, x plus 2, x plus 2. Now when I go to make my common denominator, again, easiest way, write both of these down. X minus 3, x plus 2. Then I go over to here, and anything that's not up there I have to write down. Well, the x plus 2 is there, but once I jump to the second x plus 2, it's not there. So I need another x plus 2 in this case. All right, so let's put these two examples next to each other because this is something tricky. Hopefully you can see them both. In this one, both fractions had an x plus 5. So I only needed 1 in my common denominator. But in this one, this one fraction has 2 x plus 2's in it. That's why I have to have 2 of them in the common denominator. If it had just been this one and this one, then I only need 1. But because there were 2 of them in the same fraction, I need both of those in the common denominator. All right, so let's keep going here. So now I need to make this my common denominator. So this one here, I have the x minus 3, I have the first x plus 2, but I don't have the second one. So that's what I need to multiply by on the bottom and the top. Here I have both of the x plus 2's, but I don't have the x minus 3. So I need to multiply by that. In the numerator, step number 4, distribute and combine like terms. So I get 5x squared plus 10x. Over here I get 4x minus 12. We can clean this up a little bit by writing that as x plus 2 squared, since there's 2 of them. That way we don't have to write so much. Still have to combine my like terms, so I get 5x squared, 10x and 4x is 14x, minus 12. Over my common denominator, which stays the same. So that's step number 5. And then last step again is to see if this will factor and cancel with the denominator. So 5 times 12 is 60. What multiplies to give me 60 and subtracts to give me 14? I don't think there's anything. We'll assume no. Hopefully I didn't screw up. All right, so if that doesn't factor, then there's no way it's going to cancel with the denominator. There's your answer. My restrictions, x cannot equal -2 or +3. You definitely want to make sure you try your quick checks because this is not easy. It's very confusing and easy to make a silly mistake. But if you notice, all 3 of our answers that we've just written down, they're ugly. A lot of times with adding and subtracting, your answers are not going to be nice, pretty answers like we were getting with multiplying and dividing. So don't stress out about that. That's it.